Another example of the eddy current break effect, which is due to Faraday's law, is where I have a copper tube here and a strong neodymium magnet. I'm going to take this spherical magnet and drop it down through the tube, and we're going to watch what happens as that magnet goes down through the tube. I'll drop it at this level right here, start it going down through the tube, and watch what happens as it goes down through the tube. Now take my word for it, it's still going through the tube. In fact, I can even make it fall from a position up here higher than it was to start with, still falling through the tube, and now it comes out the end of the tube. Now the reason that it fell so slowly through the tube is it went down through the tube. The copper conductor saw a changing magnetic field as the strong magnet went by. It saw at this particular point right here, for example, the magnetic field is weak. Until the magnet gets there, then the magnetic field becomes strong. That's a changing magnetic field. Changing magnetic field creates an electric field, which then drives little eddy currents in the copper, and then those eddy currents then behave like little magnets themselves, which interacting with this magnet slows it down. So those eddy currents then create magnetic fields, which causes this magnet to slow down and fall slower than it otherwise would. We'll try that experiment one more time now that you know what to watch for. We'll start the magnet up here and let it go down through the tube. And I can tell about where it is by taking another magnet here and catching it just as it comes by. There it is there. Now we'll let it fall out the rest of the way through the tube. Magnetic induction.